Hello students, today we discuss pressure exerted by a liquid column. Consider a liquid of density ρ contained in cylindrical vessel of cross-sectional area A let h be the height of liquid column and g be the acceleration due to gravity. The weight of liquid will exert a downward thrust on the bottom surface of vessel. Therefore, pressure due to liquid acts on that surface. Weight of liquid inside the vessel equals to volume into density of liquid into acceleration due to gravity. So, we can write volume equals to small a h into density of liquid will be rho as we assumed as before into g, which is the acceleration due to gravity. Now, thrust of liquid on area A equals to weight of liquid equals to A H rho G. So, liquid pressure on the base of vessel equals to thrust upon area. Thrust AH rho G upon area is A. So, we get pressure P equals to H rho G. We conclude, first point is the liquid at rest exerts equal pressure in all direction at a point inside the liquid. Second point is the liquid at rest exerts equal pressure at all those points which are at one level inside the liquid. Third point is total pressure at a depth h below the liquid surface equals to P naught plus H rho G, where P naught equals to atmospheric pressure. Next is some fact involving thrust and pressure. First is nails have a flat top but pointed end. A small pressure applied on the flat top through falling hammer becomes a large thrust. The same thrust acts on the wooden board through the pointed end of the nail. It results in a large pressure. The nail can easily be fixed in the wooden board. Now, the second is wide straps of school bags help to reduce pressure on your shoulders. Area of wide straps is more and hence pressure is less. Third, needles have pointed tip. A small force of fingers make the needle pierce into the cloth easily and sewing become quicker. Now, reducing pressure. How we can reduce pressure? First, vehicles brakes have flat surface. This reduces pressure on the vehicle tires and avoid their tearing. Second, broad sole shoes. Broad sole shoes make walking easier on the soft land. Third, white steel belt on army tank. Wide steel belt over the wheels of an army tank makes its movement easier over marshy land. Fourth is camels' foot are broad and soft. This is because they walk swiftly on sand. Next topic is buoyancy. And force of buoyancy. First, introduction. When a body is immersed in a fluid, It displaces the fluid whose volume is equal to the volume of the body immersed in the fluid. This displaced fluid exerts an upward force on the body. Now, second definition. This tendency of the displaced fluid is called buoyancy. The upward applied force is called the force of buoyancy or upthrust. It is equal to the weight of a fluid displaced by the body. For example, when a bucket is pulled out of a well, it is felt lighter so long as it remains immersed in water inside the well. It acquires its actual weight when out of water. Second example is ladies carrying water in a pitcher from a village pond enter the pond, fill the bucket and lift it onto their shoulder, keeping it immersed in water. We discuss factors on which upthrust or buoyant force depends. First, take two wooden blocks of different sizes. Push the small block inside the water in a tub and release it. You will find that the wooden block rises up and comes to the surface of water. It rises up because upthrust or buoyant force acting on it is more than its weight. Now, push the large wooden block inside the water and release it. You will find that the large block rises up faster than the small block. It means the upthrust or buoyant force acting on the large block is more than on the small block. Second example, or we can say second factor, which affect the buoyant force is, now add some salt in water so that the density of solution increases. Push a wooden block inside the solution and release it. You will find that the block rises up faster in the solution than a pure water. It means the upthrust or buoyant force acting on a body is more in a liquid having more density than in the liquid having less density. So, we conclusions are: first, the size or volume of the body immersed in liquid. This is the first factor on which buoyant force depends on. And second, it depends on the density of liquid in which the body is immersed. So, these are the two activities, these are the 2 points on which upthrust or buoyant force depends on. So, we can say the tendency of an object to float in a liquid or the power of liquid to make an object float is called buoyancy.